Hey, what's going on, everybody? So here are the answers to geologic sequencing that we started, or you started the other day. So the first one blank, I'm not going to spend too much time going over what the rock units are. You guys being earth science should already know how to use your reference table. I know I said I was going to give you this one too, which I'm totally still going to send it to you. But nonetheless, I just really cut and paste these from our earth science reference table. So here's the reference table right here with our map symbols that we have all throughout here. We did, at least I did talk about a little contact metamorphism the other day. Remember that regional is over large areas, like a mountain building process. You know, it could be from, let's say, Buffalo all the way to like Syracuse. Distance-wise, by no means do we have metamorphic rocks. In our bedrock, we are we are definitely sedimentary rocks. But nonetheless, we talked about contact metamorphism. So, for example, if you take any of the rocks we're talking about here, if you take quartz sandstone, and remember sandstone we can find up here for sandstone, and if we add some, not heat or pressure in this one, but actually contact, which is actually the interface where the intrusion is baking the rock that it touches, it becomes quartzite. You have metamorphism of limestone or dolostone is going to make marble, or pebbles may be distorted. Basically, it's a conglomerate making a metaconglomerate. Again, paying attention, these are elongated rocks or pebbles in here versus the chunky, kind of weird, no really general shape up here for the conglomerate ones. But again, you also have the sheet right here, which also has the igneous rock symbols for that. So for this one, we definitely have horizontality right here. The rocks are deposited horizontally. We have superposition definitely taking place right here. So here we have A is being deposited first, followed by M, then K was deposited, then E, then D, then the fault. How do we know the fault's last? Because it cross cuts through all the different layers. And also remember, you have to have a rock there in order to break it. It's pretty hard to break your arm if there's no arm there. It's hard to put a hole in the wall if there's no wall there. So in order to put a hole in the wall has to be there first. In order to break your arm, you have to have a bone there first to break. So therefore, it's the last act to happen in the sequence right here. And this one right here, A is deposited, then K, then O, then S, then G, then B, and then it was folded, is what's happening along here. If we take a look at this one right here, D was deposited first, followed by B, followed by K, followed by A. Then there was tilting, because remember horizontality, that rocks are deposited horizontally. These are not horizontal. These have been tilted. So there's some kind of a force happening right there, so they're tilted. And then we have erosion taking place. How do we know erosion? Well, we see a flat line right here where then all of a sudden they start to be deposited horizontally. So the only way that's going to happen if they were eroded, and then you have something put on top of it, and then so then S would be put on top of it. We're going to stay away from terms like emerging, submerging. We should know that when you uplift something, there is erosion. I mean, we could probably right after A, right here, after tilting, we could probably put the word uplift. But remember, in our reference table, which I happen to have right here, that when we talk about the word uplifting, we were also talking about weathering and erosion. So remember, those kind of words go hand in hand because we talked in the last unit. When things get pushed up, there are leveling forces that want to break it down. Wind, water, ice, and gravity try to bust all that stuff down. But I didn't bother to include it. Again, we're modified here in what we're doing for the circumstances. Here we go. For this one, what's happening right here? Remember, D is an igneous intrusion. I said that the last slide, last class. So A is deposited, then D, then erosion, E, and then G. So you might be thinking, why? What's cooking here? Well, we know A was deposited, and then we know D came through. And we know D came through next because there is contact metamorphism all along this interface right here. All along right here, we would expect to find quartzite, and then it would transition to sandstone. But if you take a look up here in this limestone right here, limestone is not baked at all. There's no contact metamorphism. So what does that tell us? It tells us that there was probably erosion, or we could say it cooled, you know, whatever. But nonetheless, there's erosion, it cooled, and then limestone was put down on top, deposited, and then finally shale for this example right here. So there's one clue that we have something going on right here that we can tell that this igneous intrusion did not get sandwiched in between A and E while E was still around because E wasn't there. Otherwise, it would have been baked, and we don't have this contact metamorphism symbols right along here, along the interface right here. And if you did your reading, you'd know if you have an igneous intrusion right here, and then a sedimentary rock, you know this is one type of a unconformity. There's three types. There's a bunch of unconform. There's a unconformity, angular unconformity, and then a disconformity. Either way, the rock units do not match up. I can't tell you which one it is. I feel like it's a disconformity where you have an igneous rock along with a sedimentary rock, but don't quote me on that one. Here is an example of another igneous intrusion. So D was deposited, then C, then G, F, and then finally Z. How do we know Z was last? Well, if you take a look, when Z comes through, that igneous intrusion, it bakes all the rocks. And so because it baked all of them, that means it was the last thing to come through in this sequence. So here we expect to find marble. Here we expect to find quartz sandstone. Quartzite, quartzite along here. The shale, it'd be baked, and what we would throw underneath that category, looking at Earth Science reference table, it's contact. We don't really have anything for shale or anything like that. So various rocks changed by heat, so that we would call that a hornfels within that area right there. So there'd be hornfels along here. And we'd also, here we have conglomerate. We would say that that's probably metaconglomerate right here, and then it transitions back into conglomerate. Here, hornfels transitions back into shale. Here we have quartzite back into sandstone, and then here we have marble back into limestone over here. So here's an example of contact metamorphism. It's just like, you have a light bulb on and you put your hand on it. You're going to burn that first layer of skin that's touching the light bulb, and the rest of the skin underneath is okay. Same kind of deal with this. We talk about contact metamorphism for this. This one, pretty straightforward. C, B, A, D, and then E. So we have some cross-cutting relationships. So we can see that D cross-cuts across all of these. I know there's some of them don't show that there's metamorphic contact metamorphism. It's just the degree of basically of what's trying to be conveyed in these diagrams. But we know that this is an igneous intrusion. This would all be baked along here. But we do know that the fault is the last thing because it breaks through everything. We can also assume that underneath this B, there is this layer C. It's just cut off from the picture. So here's an example of what's happening there in this diagram. On this baby right here, C, D, F, K, then the fault, and then you have the intrusion coming right here with this contact metamorphic zone all in there. Next one, A, B, T, Q. Again, I just randomly assign letters to here. Then P, then the fault. So we know the fault is the last thing to come through here because it actually cuts through cross-cutting relationships, cuts through this igneous intrusion, which happened to bake all the rock. Which actually baked all the rocks. So that's what's happening in this particular picture right here. This block right here, slide 21. A was deposited. Well, there's actually two answers to this one. So there are two possible answers. A was deposited, K was deposited, C was deposited, F was deposited. Now, we don't know anything about C. There's really nothing to say C in relation to P and D for what to do here. So S could have been last. I could have thrown after S, and then PD, and then throw the S out over here. But it doesn't really make a difference for what we're doing. But you could have S being the last thing deposited. I just happened to throw it under as after P because it's sitting on top of it. Again, there's two possible answers. So what I'm shooting for in this one is A, K, C, F, S, and then P came through. And it has contact metamorphism, all the stuff right here. And then D is the last thing to come through. Cross-cutting relationships. If it crosses in front of it or on top of it, it's one of the last things to happen in all of this. So again, there is two possible answers you could have there. And you'll find that from here on. From time to time, there'll be some different answers. An unconformity. So I've asked you to look up and read some stuff in your red review book about an unconformity. basically, everything with the word conformity, everything's the same. Unconformity, you have some differences right here. So if we start off with a block right here, you have horizontality, they're all horizontal, and superposition, which is the oldest, and that is the youngest. Then we have maybe you have two plates coming together or something like that tectonically, or orogeny happening, boom, you get squeezed from either directions, and now we get folding. Then an erosion event comes through. So this right here is an erosion event. You can see there's uplifting. And some diagrams you'll see a squiggly line, or it won't be a straight line, it'll kind of be a broken line, and that is indicating that that's an erosional feature. And then on top of it, we have this we actually have fresh layers put on top. So the unconformity is this boundary where this line is right here, we have all these bent, folded rocks, and then it becomes horizontal again. So this is an example of an unconformity is. So an unconformity is where you have a change in environments. We actually can see a little bit more squigglies if we give me a chance right here to go back up here. Here's the one for Niagara Falls, and you can see it's not a straight line across here. So we know here there is an erosion of some rock record. It could be missing, God knows what happened to it, but nonetheless, it just, after the Queenston Shale, it wasn't the whirlpool right on top of it. There's probably some other rocks, there's some erosional features there that tell us that this is an unconformity. You also see it right here, there's also an unconformity along here. So really there's missing rock layers or a gap in the rock record. We have a ton of unconformities right here in the Grand Canyon. Here's the great unconformity. Don't quote me, but there is a ton of time missing in the Grand Canyon. Just eroded away. No one ever knows what happened to it, what the environment was. You probably look in other areas, but you have a great unconformity right here in this zone in the Grand Canyon. So back to my point on this one, an unconformity is where you have a change in depositional structure, and that you have from the folding from here. Angular unconformity. This was what an angular unconformity would be like. So these are on an angle, you have a straight line, and then it's back on horizontal. This would be an angular unconformity. You are not responsible for knowing an angular unconformity or disconformity, but you should be able to recognize that this line probably should be squiggly, and you have some erosion occurring there along that line, and that would represent an unconformity. These are a piece of cake. A, B, C, and then finally D. They show that beautifully. This one's pretty straightforward too. A, then B, then C, then D, then E, then folding, then erosion. There's the squiggly line, and then there's F right there that goes on top. Going on to this one right here. A was deposited, B, C. Oh, got a double on right there. D was deposited. Then you have folding that occurs. Then erosion. There's an erosional feature. Notice it's not a nice flat line, it's a squiggly line, so you have erosion happening right there. And then E was deposited, and then F was deposited. Going on to the last one. Maybe the last one. This one is, again, just like the one I just talked about a second ago. A was deposited. B, C, D. Then we have tilted. Then we have erosion. So there's the unconformity right there. And then lastly, E was deposited on top for that one. Oh, I misspoke. And then here is the last one. A, B, C, D, E, folding, erosion, F, and then, I don't know why I put a D. Change it right now to G is what that should be in that particular one right there. Okay. Now, these two, you'll find out later about these two. This is slide 28, and then this one right here is slide 29. I'll give you further directions about that. So again, please, if you have any questions, watch the video over again, see if there's something you might have missed, because I am kind of talking a little bit fast. And then if you still have questions, please use Google Classroom, public comments, get this all cleared up, and we should be all good. So again, relative dating, this is older than this. Pretty basic, straightforward stuff. So be safe. Got any questions, let me know, and I'll talk to you later.